Hello, and welcome to my networking capstone project. Throughout the course of this video, I'm going to be going over my project goals, my networking diagram, and demonstrating how everything works within VirtualBox environment. So let's start with the overall goal of this project. The overall goal of this project was to create a site-to-site VPN, allowing two different buildings to connect to each other via VPN. The reason I wanted to do this is, as you can see on the diagram on the left-hand side, this is my headquarters network. My headquarters network is already established, it already exists, and already has a bunch of shared folders, files, and a perfectly good working network. So to make it easy on myself and less expensive, for my second network, I'm going to be connecting from the branch office to the headquarters office to retain all of the files, shared folders, domain controller, domain users, and everything that the headquarters network had previously. This also makes managing computers and users very easily remotely because, say, the IT team is working from the headquarters network, instead of having to hire someone or physically driving to the branch location, they could just remote into the network very easily, even just using a tool like RDP, which is already built into Windows. The reason that they can do that is through the VPN. As far as both of those networks know, they think they're connected together as one internal network. This project was really targeted around VPN users. So as you can see on the top right hand side of my diagram, I also added a VPN user that's going to be outside of both of those networks, but still able to connect via VPN into the headquarters internal network. The third and final goal was to create an offsite backup solution in order to back up all the files that are being built up on the shared drive workstation. So let's go take a little look at both of the diagrams. As you can see on the left-hand side, this is the initial diagram that I proposed. From what you can easily tell, the second diagram looks vastly different compared to the initial one. Some of the reasons for including this is to make my network more optimal, easier to manage, as well as I was having connectivity issues beforehand. So for example, by being optimal, I mean instead of having a VIOS router like I proposed on the initial network, I just turned the firewall into not only a firewall, a VPN, as well as a router for the internal network. This also makes it a lot easier to manage with one less networking device to take care of. Having the firewall as the router was not only easier, but makes the network more optimal and easier to take care of. So let's just take a little look at the diagram. So essentially for my headquarters network, which is displayed on the left-hand side, I have my firewall, which acts as my VPN router as well as my firewall. And under the firewall, you can see two workstations. One of them is going to be a shared drive Windows, which means it's going to be a Windows 10 box that holds a shared drive that is used commonly over the network, accessed by anybody who's connected to the pico.local domain. The second device you can see is a Windows 2016 server, which is going to be hosting my DNS, my Active Directory, and the domain controller. As for the right-hand side of the diagram, this is going to be my branch network, so like a branch location, where this one also has a firewall configured with a VPN, firewall, and acts as a router as well. Under that firewall, you can see that we have one workstation. This is just to demonstrate that the VPN is working correctly, and from the right-hand side of the network, once the VPN is established, that we will be able to connect all the way to the other side onto the internal network of the headquarters and ping these two machines. Other parts of this diagram include, for example, on the top left side, this is going to be our offsite backup server, which is going to be accessed over the internet from the shared drive workstation, which is found on the headquarters network, where we are hosting the common shared folder. We can also see on the top right-hand side our VPN laptop, which we will be using as an example to show a remote user off the grid from both internal networks and to show that it can connect into the headquarters internal network. So let's start going over the machines into our virtual network and how our infrastructure is set up. So as you can see in VirtualBox, we have all of the machines that are displayed on our diagram. Like for example, our server 2016 machine right here will be this machine on the diagram right here. Workstation is going to be this machine right here. And then our OpenSense server is going to be our firewall on the diagram right here. So let's start to go over the configuration of these machines and how I set them up on the network. So for server 2016, if we jump into the settings, The only configuration that I have done is change the network into an internal network. This internal network is going to be this guy right here, which is connecting up to the firewall VPN, which also has an internal network of the name network 1. That is how the firewall and the server 2016 machine are going to be able to talk to each other in order to send traffic out on the internet. If we move into the general tab, this is just to show that it is a Windows 2016, essentially server 2016 machine that is running. So let's go to our next machine. So the shared drive workstation, this one is pretty much the same thing, where this one is running Windows 10 and has a network configuration of internal network and network 1. So let's go to our next machine, and this is going to be the OpenSense server. So if we check these settings, you can see that it's running off of FreeBSD as the operating system. And for our network configuration, we have an internal network of name network 1, which means all the 3 devices on the headquarters network are connected to each other via the internal network. The firewall also contains a second adapter, which is a bridged adapter, which allows us to connect to the internet. As for the rest of the machines, the OpenSense client is configured very similarly to the OpenSense server, where it has a bridged adapter and internal network of network 2. Now, network 2 is going to be the second internal network, which is this guy over here on the diagram on the right hand side, which is going to connect to the laptop. And as I will show you, the branch client, which is going to be this laptop right here, also has the same internal network as the second firewall. As for our 2 other machines, we have the offsite server and VPN client. They are both running a bridge adapter to connect over the internet. The reason they don't have an internal is because we're supposed to simulate that they are coming from the outside of the network, which is why they have a bridge adapter attached to them and not an internal network, because they do not belong to any of the firewall internal networks. They are offsite computers or workstations. So let's do a little bit of demonstration. We're going to start off with our OpenSense server and OpenSense client. So as we can see, both of these machines are currently running the server and the client. I'm just going to drag them over. So as we can see, after logging into the machines, we can see how they are configured. So from the OpenSense server, which is going to be our headquarters network right here, it has a LAN IP address of 192.168.1.15. This is going to be our internal network, network 1. We can also see that we have a second interface, which is a WAN interface. This is the bridged adapter interface, which allows us to connect out onto the internet with an IP address of 192.168.11.53. We have a very similar configuration for the OpenSense client, which is this machine right here, and going to be on the right hand side of the network, this guy right here. We can see that the IP address for the LAN is very similar, the 192.168.2.15 as opposed to 1, and that's because we are on the second network, which we named network 2 for our internal network. We can also see that we have a WAN address, which helps us connect out onto the internet, and that is the bridge adapter with an IP address of 192.168.11.54. We can also see on this machine that we have a third interface, which is for the VPN exclusively done through a tunnel. Because it's done through a tunnel, it uses the WAN interface to connect out onto the internet and find the other VPN host, as opposed to creating an actual physical adapter, which is why we only have 2 physical adapters connected to this client machine and 3 interfaces in total. So in order to see the rest of the configuration for the firewalls, we're going to need to access them via the GUI. So in order to do that, I have to start up 2 workstations, and then we're going to log into them using their LAN interfaces, using the 192.168.1.15 and the 2.15. So let me just drag these machines over. So this machine is going to be used for our internal headquarters network. So right now we are using the shared drive Windows workstation machine. And as you can see, we have logged into the 192.168.1.15, and now we're able to access the GUI of the firewall. We also have the GUI interface for our second network, which we can find back on the diagram right over here. So for the virtual machine on the right hand side, we can see that we are connecting to the 192.168.2.15 address, which belongs to this firewall right here. And right now we are connecting from this laptop on the diagram. So let's start to go through the configuration a little bit now that we know how this is networked and mapped out. As you can see, when we scroll down on both machines, we can see the interface addresses, like the 192.168.1.15 over here, and the 192.168.11.53 on this side, which is our WAN address. We could also see it on this side over here. We can also see extra addresses, like the 192.168.70.2, but later we're going to go into that, as that is our firewall virtual network. As you can see, we have additional IP addresses, like the 192.168.70.2, as well as 76.1 and 70 70.1. As you can see, we also have additional IP addresses like the 192.168.70.2. We have a 70.1 and a 71.6, and those will be our VPN addresses over the tunnel. So let's start going over the VPN part of this project. So if we go to on the GUI interface, on the VPN tab, open VPN and connection status, we can see that we have an active connection from the 192.168.11.54, which is the IP address of this firewall, as we can see right over here. So if we check on this guy over here too, VPN, open VPN, and connection status, we can see that we have a connection that is up, which the remote host is the 192.168.11.53, which belongs to the machine on the left-hand side, which also belongs to the headquarters network. To confirm that the firewall is working properly, I'm going to open a command prompt, and from here we're going to ping the interface of the remote firewall, which if we go back to the OpenSense dashboard and scroll down is 192.168.11.54. So if I go back to my command prompt and do 192.168.11.54, we have a successful ping. To show additionally that the VPN is actually working, I'm going to go to the second workstation and open up a command prompt. And then if we go back to our first one, we're going to type in ipconfig, and we can see that we have the address of 192.168.1.20. So if we go to our second workstation and we type in ping 192.168.1.20, we have a successful ping to this machine. So just to go back and show you on the diagram, essentially we're pinging from this machine on the laptop all the way over the network. So going through the firewall to the VPN connection to the other firewall. So that's on the bridge interfaces through the internal network all the way down to the shared drive. Now, just to prove that the VPN is actually working, we're going to minimize this. We're going to go back and we're going to go to the home interface of our firewalls. We're going to scroll down on each until we see OpenVPN. If I decide to stop this service, so we're going to stop OpenVPN, and we're also going to stop it on the server VPN. I'm going to wait for that to finish. And now we go back to our command prompt on the second machine. If we just do up arrow and try to ping again, we get no results and nothing is working. So now for the sake of our network and making sure it connects back, we're going to go back to the home interfaces on our firewalls, and we're going to start the OpenVPN service again. So we're going to just press start on that little arrow there. We're going to wait a second, and then we're going to check the connection status on each. So that's VPN, OpenVPN connection status, and we're going to do that on both, just to make sure that the connection is up, and we can see that the connection is already up status, which means we go back to our command prompt, and we do up arrow, we should be able to ping just fine. And there it is. We're able to ping back to that machine, back onto the headquarters internal network. If we wanted to, that's not the only machine that we can ping on that network. Remember, we have a server 2016 machine on there, and that has the IP address of 192.168.1.40. So I just did up arrow, and I'm going to replace the 20 with 40. I'm going to enter, and we can see that we can ping that server as well. So now that I've demonstrated that it actually works, let's go a little bit into the configuration and see just how it works. So in order to do that, we're going to go to our headquarters VPN first. So in order to do that, we need to go to VPN, open VPN, and servers. So the headquarters is acting as the server, and the remote is acting as a client. So we need to go to VPN, open VPN, and clients. On the left-hand side, you can see that I have two servers, and that's because I have one for a site-to-site connection and one for user authentication for remote users. I'll go into the second one a little bit later, but for now, we're going to click on Edit and check the settings for the OpenVPN. We're also going to click the settings for the client machine as well, and then we're just going to look through a little bit and explain how this works. So for the server side, that we could see that the server mode is shared key. Peer-to-peer shared key. So what this means is that they're going to be using a shared key to authenticate each other, and that's from the server to the client. We can see the shared key if we just scroll down a little bit more, and we can see it highlighted right here in this text box. And this is the key that they use in order to authenticate each other. A little more through the settings, we could see that we're using the UDP protocol to talk to each other. Device mode is tunnel. Interface, we're using the WAN interface to talk to each other. So that's the bridged adapter on both firewall machines. Using the local port 11.94. If we scroll down a little bit, we could see a couple of the encryption algorithms and methods. And this is very important because it has to be identical on both. And I will show you that just in a second on the client side. If we scroll down a little bit more, we can see the IPv4 tunnel network, and that's the 192.168.70.0. Now, if this looks familiar, that's because if we go back onto our dashboard and we scroll down a little bit, we can see that address right over here. You can see the 192.168.70.1, and that is the remote virtual IP that the server is going to use. Now, the last digit of this IP doesn't really matter because it uses DHCP. So now if we go back to our configuration, just clicking on the back arrow, and we start scrolling down a little bit, there's a couple of settings that are important here. So IPv4 local network. So this is the local network that we're using, and I'll show you on the diagram. We're saying that this firewall is allowing this firewall, so from the headquarters to the branch, to connect to the .1 network. And this is important because we're only using the .1 network for our client machines. If we had two networks, like a .1 and .2, we could set it to only .1 machines are allowed to be remoted into, while the .2 machines stay off of the VPN connection. Now let's go back to our configuration, and from down here, we could see the IPv4 remote network. This is the .2 network. So that, if we go back to the diagram once again, is this network over here. So we're saying if you are coming from the .2 network on this side, you're allowed to connect to the .1 network on the headquarters side. So let's just finish up a little bit here. And that's pretty much the whole configuration on the server side. So if we go to the client side, we can see that the peer-to-peer shared key is the same. So if we scroll back up, the settings are identical, as well as UDP, tunnel, outside WAN. Now over here is important because the remote server, or the host, is 192.168.11.53. This address is the address that belongs to the bridged adapter on the headquarters firewall. So we can double check that if we go back to the dashboard and then we scroll down a little bit and we can see that the outside WAN interface has an IP of 192.168.11.53. So that's how they're going to talk to each other. As for the client, if we just scroll down a little bit more, we can see the shared key. We can see the identical encryption algorithm, authentication digest. We could also see the IPv4 tunnel network, which is 192.168.70.0, and that's just the network that we're going to be using for tunneling, and as well as the IPv4 remote network. So we're saying that we're allowing ourselves into the .1 network. Over here, if we scroll down a little bit more, is also important, limit outgoing bandwidth. So this isn't really readable because it's in bytes, but basically that translates to 100 megabits per second, which means we're only allowing 100 megabits per second connection outside back to the other firewall. And as we can see, we included that on our diagram that we wanted a 100 megabit connection limit. So to go back to our client side here, that's pretty much the whole configuration, and that's how we set up our VPN for the site-to-site connection. So we can minimize this and minimize the branch machine because now we are going to be putting our focus on the VPN laptop. So instead of a site-to-site connection, now it's going to be from the firewall to an outside client, which is over here. So let's look at the way that that has been configured for our firewall. So if we go down to VPN, open VPN and servers, because remember this is acting as a server, we can see that we have our first server, which was used for the site-to-site, and we also have a second one, which is for clients. So let's just click on edit over here to check the configuration. So to start off, we can see that our server mode is for remote access, which means instead of peer-to-peer, it's only going to be remote access users that can use this VPN connection. So just to scroll down and go through the settings, we can see that it's pretty similar to the one that we had before in the sense where we have the same protocol, device mode, and as well as the interface is the same. But now we have to use a different local port because this is a different VPN connection than the site-to-site. If we scroll down a little bit, we can see that we also have a key that the client is going to use to connect to this server. We can see if we scroll down a little bit more that we have a certificate that we have created beforehand before setting up this server. We also have the encryption algorithm to be very similar, but this one is a lot more secure, as in we're using a higher bit because if we're coming from the outside, we really want to make sure that it's going to be as secure as possible for remote devices. So let's just scroll down more. We can see that the IPv4 tunnel network is configured as 192.168.71.0, not 70. So this is a completely different network compared to our other server. And we can also see that the IPv4 local network is going to be the 192.168.1.0, which means we're allowing the remote to have access to our network to be able to ping these devices and connect to them via VPN. So if you scroll down more, that's pretty much all the configuration that we need. So now we're going to demonstrate that this connection is actually working. So first, let's go to our dashboard to make sure the connection is up and running. So if we scroll down a little bit, we could see my SSL VPN server, which is going to be our remote server for our clients like the VPN laptop. And we can see that it's currently running. So let's bring up our VPN laptop, which I'm going to drag over here. So this is our VPN laptop. And in order to connect to the VPN, we're going to be using a tool called Viscosity. It's important we use Viscosity because if we go down to VPN, Open VPN, client export, we're going to change our remote access server to the SSL, which is the remote, and export type has been set to Viscosity. So if we scroll down and then we go to account certificates, and we click on the download button here, it will download a copy of the viscosity file to which we have to copy over to this machine, which happens to be this file on the desktop over here. So let's maximize our machine here just to demonstrate that it is working. So we're going to drag this over and we're just going to double click the file and we're going to wait a second and we can see that the connection has been imported successfully. So now we have to click on OK and we go down to the little arrow. We're going to click it and you can see this little circle here. This is viscosity. So in order to connect to the VPN, we're going to right click and connect to my SSL VPN server. So once I click on this, it's going to ask for a username and password. So for the username, I have configured it as B Brown or Bob Brown, which I have configured in the firewall. And for the password, this is the interesting part because for the password, I have enabled Google Authenticator. So I have to go to my phone, get the Google authentication code, type it in, and then type in the password afterwards. So my Google Authenticator at the moment is 972775, and then I have to type in my password right afterwards. And then once I have entered that, I click on OK, and then we're just going to wait a second for it to connect. And now we can see that it has officially connected. So let's go down to viscosity. I'm going to click on this arrow. We're going to right click, and then we're going to do details. We can see that currently we are connected. We have been connected for 16 seconds, and we are connected to the 192.168.11.53, which is the IP address of the bridge adapter. So to demonstrate this is working, we're going to do the test that we did earlier with command prompt. So we're going to open up command prompt, and we're going to ping the internal devices on the firewall. So for example, we're going to use the 192.168.1.40. If we click on enter, we can see that we get a ping, and this is our server machine. So this is the 192.168.1.40 machine. And we could also see that we have a second machine for .1.20. So we're going to try to ping that one as well. So we're going to do up arrow and then 20. And we can see that we can ping this machine as well. And just to show that this one is working, we're going to bring this back over. And then we're going to stop this service and see if we can still ping it. So we scroll down going through the dashboard. And we can see the service right here. We're going to stop the service. And then now that the service has stopped, if we scroll back down, we can see that it has stopped. And we go back to this machine, do up arrow, and try to ping again. We get nothing back. This is because the VPN connection is over, whether viscosity is reporting it or not. So if we go back to viscosity and we go back to details, it thinks it's still connected. So it still needs time to update. But what we can do is if we close this and then we re-enable the connection and wait a second, so we can see that it is now up. If we try to ping the machine again, it still won't let us. And that's because we have restarted the service, which means we need to connect back to the VPN. And as we can see, I got a little prompt right here that says authentication failed. So that means we need to type in our credentials again to make sure it connects. So we're going to click on OK. And then we're going to type in our credentials with our Google Authenticator and password. Then we're going to click on enter. We're going to wait a second and see if it's connecting properly. We're going to do details. And we can see that it has connected again, which means if we go back to our command prompt and then we type the command ping 192.168.1.40 again, and click enter, we can now ping the machine once again. So that's it for the VPN section. So now we're going to go over the backup solution. So we're going to minimize our VPN clients and we're going to open our offsite machine. So we're just going to drag our offsite server on the screen over here. And since we're not using our firewall anymore, we're going to minimize this. We're also going to close the command prompt. And as we can see, we're using the shared drive workstation already, which is the machine we're going to use to connect to the offsite server and make backups with. So in order to start this, Sync Tracer already starts automatically in the background, but we are just going to open it up on both machines. So now that the applications have opened up on both machines, we can see that if we scroll down on our shared drive workstation, that we have a remote device connected and it is called Offsite. And if we scroll down on this side, we can see that we have a remote device called log server. This means that they are connected to each other, they're up to date, and they will be talking to each other to do backup and sync data. So the way this thing works is that Sync Tracer creates a folder, and then we can check that over here. So under folders, we can see the folder path is C, users, FPET, and shared drive. This folder is significant because this is the folder that is going to be sharing onto the other device, which happens to be the offsite device, and it's going to share all the files that are stored in here onto the other machine. So if we navigate to that path by opening File Explorer, you're going to go C drive, local C, users, FPET, and then shared drive. We can see that we already have a test folder and a test text document in here. Now if we go to the other side and open up File Explorer, going to go this PC, C drive, users, offsite, and then shared drive, we can see that we have identical files. That's because they have already synced. But what happens if I create something new on this device? I'm going to go create text document, and then we're going to do test number 2, and then enter. We're going to see that it doesn't instantly pop up on this machine, and that's because they need to sync to each other. And the way I've programmed this is to sync every 5 minutes. Now, in reality, this would be very extreme because you don't need to create backups every 5 minutes. But because this is a virtual network and virtual scenario, it's better to set it this way. That way, we can see our files showing up in 5 minutes as opposed to just 1 week. So from here, we're going to close this. You can see under folders, under shared drive, we're going to click on the edit button, and then we're going to click on the advanced tab. And over here, we could see full rescan intervals every 300 seconds. This is every 5 minutes, which means it's going to check every 5 minutes for documents to sync up with the remote server. So from here, it's very cool because from the advanced tab, we could change the folder type to send and receive. That way they sync back up to each other all the time. So whatever changes I make on the offsite server will also go back onto the shared drive. But we don't want that. We want this to be an offsite backup. So we're going to change this to receive only files. Going to click on save. And then on this device over here, we're going to do edit, advanced, folder type, and then send only. Like I said, this is very important because we only want this network to send files onto our backup server, which is the device on the right hand side. And we only want this guy to receive, that way it can store files. So we're going to give this anywhere from 5 to 10 minutes. That way our file on our shared drive, the test number 2, can sync up on the offsite server. Okay, so now we're back and we waited a while, which means by now it should have updated and received the files. So if we go to our File Explorer and go back to the same one we had opened before, we can see that we received test number 2. So obviously it's an empty file because we never put anything in it, but this just goes to show that it's working perfectly fine. Um, the offsite server can receive files and store them as backups, and the shared drive workstation can send files onto an offsite backup server. Initially in my diagram, I said that I would be using PowerShell using SCP in order to transfer files from one site to another. But this tool seemed to prove to be a lot easier and can sync every 5 minutes and sends files encrypted end to end, and also has the ability to sync files together if I really wanted to. But in this case, we only want to do a sender and a receiver, and this tool has made it super easy for that. And any information that was created 5 minutes ago will be automatically backed up onto the offsite server, which is very convenient if you create a file and lose it very quickly. So now that we don't need the offsite server anymore, we're just going to minimize this. We're also going to minimize our shared drive workstation, and we're going to open up the initial proposal in order to look at our goals and see if we succeeded them. So as you can see, for the most part, technology used has remained the same, excluding those like Vios, which just caused me internet issues. So I opted out of Vios and just used OpenSense as my router instead, which made it easier and allowed everything to connect properly. The other tools as well is AxeCrypt, which I initially used for encrypting files. That way I can send them offsite to backup. But luckily SyncTracer allowed me to do everything automatically and encrypts all the files. As for PowerShell, I also opted out of it because SyncTracer allowed me to do PowerShell and AskScript in just one program and combine them together. So now let's just scroll up to our goals a little bit and see if we met most of them. So for our project goals, the first one was creating firewall configuration and to allow users offsite, which we have been able to create using the headquarters firewall and the VPN laptop. For the second goal, we said that we wanted to log users onto the VPN via Windows, but we opted for creating users on the firewall. That way, not anybody has access to the VPN at any time, only specific users are allowed to. Creating the users on the firewall has also allowed us to do two-factor authentication as opposed to just logging in with your LDAP credentials. As for the third goal, we said we wanted to log server attempts for every time someone tried to connect. We weren't able to grab the log files off of the VPN server and offload them somewhere else. So instead, we opted for just a backup server and creating a shared drive for everybody to use. For the PowerShell section, I already went over that and said that we just didn't use it because of SyncTracer allowed us to do everything automatically with just an application. For our fifth goal, we said we wanted to create a file server to host the shared drive, and which we did, which the shared drive has a common network drive for everybody to use. For the offsite backup, we said we want to log files or put log files into the backup, but instead we opted for just documents and folders. VLANs have proved to not be useful due to only having a couple devices on our networks and using devices over the VPN. For the VPN configuration, we said we wanted a VPN bridge between two locations, which we did successfully do from the headquarters VPN to the branch VPN. And the second part to that was allow the branch building to have 100 megabit per second throughput to the headquarters, which we were able to do. For the next part, we said that we wanted to log. For the next part, we said we wanted to log failed attempts. That way, if someone failed to authenticate twice, we would block them off the connection. But we proved not to have to do this because we have Google Authenticator, so it'd be extremely hard for someone to get in anyways, unless they had access to the phone, user's credentials, and their computer. As for the last part, we said we wanted to set up a basic infrastructure. So we created a domain controller, which we did on the Windows server. The next part to that was the DNS server, which we also did on the Windows 2016 server using the 192.168.1.40 address. As to the next part, we said we want to do a DHCP server, but instead we opted to do static devices, simply because we don't have many devices on our network. And the last part was Active Directory, which we were able to do on our Windows 2016 server. And just to prove that all of these things work, I'm going to go back to my shared drive Windows workstation. And from here, if we minimize it, first let's check that we are connected to the domain controller. So we're going to go to Control Panel, System, Change Settings, Change, and we can see that we are connected to the domain. Now, if we go to our server, which I'm going to drag over here, we're going to prove that this is the domain. So if we open Server Manager, and then we go to the Local Server tab, we could see that our work group or domain is pico.local. To also prove that our DNS works properly, let's go to our DNS settings, and we can see that DNS has the IP address of 192.168.1.40. So if we go back to our shared drive, and we go to the CMD, we're going to do an ipconfig/all. We can see that if we scroll up on our interface, that the DNS server is 192.168.1.40, which means if we try to ping google.ca, we can successfully get a ping back using the DNS server. The last part is being able to log in with Active Directory users. So if we go back to our Windows 2016, we're going to check Active Directory. I'm going to minimize Server Manager, and we can see that under Pico users, we have administrators, Burlington Office users, Oakville Office users, which is the remote, and Burlington is the headquarters, and we have VPN users. So let's just take one at random. We're going to say the Oakville user, so John Smith. So we could see going to John Smith's properties that his user login name is jsmith, and the password, we're going to type it in. So let's go to our shared drive workstation. We're going to quickly log out of the user. And then now we're going to try to log back in. So currently we're logged in as Tony Green, but we're going to do other user and we're going to sign into Pico using the Pico domain. We're going to type in jsmith and then enter the password. And we can see that it instantly recognizes John Smith, as John Smith is one of our users. Now we can see that we have successfully logged in as John Smith's account. And in order to check that, we're going to check the account settings. So change account settings. And we're currently logged in as pico/jsmith. So that about wraps up my capstone presentation, and thank you for watching.